Hello, everybody. Our next presenter is James Hannon. He is the Technology Solution Professional at ExxonMobil, and he will be discussing turbine oil triage. You can find out more about him and connect in the speaker profiles.
Hello. I guess I turned over to me, so thank you. My name is Jim Hannon. I'm with ExxonMobil, and I'm going to talk to you about from a turbine oil operator's perspective on things they will consider when an upcoming overhaul or they've had an unscheduled outage. And the last, oftentimes they're thinking, well, what to do with my turbine oil? And so what we'll do is today we'll talk through different scenarios and determine which is the optimum direction for the turbine operator to go with his turbine oil. And I'm assuming you can see my screen here. The things we want to talk about is what that person's going to need to do to prepare for this overhaul interval, and also looking at what the customer's concerns are. Are we thinking about an oil change, at oil life extension? Are we looking to correct an operational issue, whether it's elevated bearing temperatures, excessive filter plugging, valve sticking, those types of things? So all that is part of what the customer's expectation or the turbine oil operator expectations are, and then what we're going to do is try to step through that in a process that helps define the optimum solution. So first step is gathering data. And so we need to know simple things like the equipment type, the make and the model, that type of thing. And then what is the current oil that's in service today? And then how many hours are on that oil? Understanding the hours is a critical part because an oil supplier is going to have an assessment on turbine oil life expectancy under certain circumstances and certain applications. And then also review equipment inspection records. And so look for whether we've had maintenance issues associated with servo valve sticking, regulators that stick, bearings that have elevated temperatures, reservoirs that have excessive signs of varnish, and things like the hydrogen seal may be also a problematic area too. So we'd look for those kind of inputs to confirm that when we plan for our outage, we're making the right steps. We'd also ask for a history of temperature and pressure variations, looking at bearing temperatures and pressures. We'd look for temperature spikes in the bearings. We'd also look for any kind of lube oil pressure drops that may be indicating that you've got a sticking lube oil regulator. And you look for anomalies and drill down on that. One thing we're hoping is that a customer is using a well-established oil analysis program. We happen to have one called MobilServe MSLA that would look at the key tests of concern for us. And I've got those listed below here. RPVOT, acid number, ultracentrifuge, MPC, ruler, and FTI for oxidation. And you might see that some people have just moved to one or two tests, but we've found over the years that it's really the battery of these tests give us the full picture as to the condition of that oil, especially when they're going to make a major decision on their upcoming outage that could be over $100,000 worth of capital. As they pull that data together, they're going to kind of interweave that with what their goals are. Are they looking at this as an oil change at the overhaul, or are they looking at the oil's end of service and approaching a time for some kind of activity to improve the life of that oil? Or maybe they're looking for a potential for a life extension on that oil. So from that, we have developed a triage chart, if you will, and this is very detailed, and you won't be able to read it on this screen, but I'll just show you the big picture of it, and you can see up in the upper right-hand corner is where we would start, and basically, as we go through a series of questions that are based on the gathering of information that we just discussed, it starts steering us into whether we're in good condition, whether in moderate condition, or whether we're in severe condition. And each one of those will dictate a direction, a path forward to us for discussion as to which way we should take this practice here. In when you start digging into it, you'll see this chart that again got a lot of information on it, but the key elements would be if the oil is good, you might be just looking at a drain, and there's reasons why you would just do a drain because the oil is good. Maybe you're looking to upgrade oil chemistry, and this is your opportunity to do it, and maybe the conditions are such that with compatibility that a drain to less than 5% is sufficient. Maybe your oil is still good, but you've got an interest in doing an extra level of support for the oncoming oil, and we would look at doing a displacement flush. And that's we would look at the oil and say, okay, I've done my oil analysis and everything looks good. I've got no operational issues, but I'm looking to convert to a higher quality product that maybe does require a displacement flush. And then there's different steps within a displacement flush. Typically, when you do a displacement flush, you're looking at 2/3 of the system volume for the displacement flush. And that's carried out over typically a period of 8 hours. Then if the severity of the oil and condition becomes more severe, called moderate, basically we would say any one sign of varnish, whether it's an operational issue or whether it's MSLA, an oil analysis test that's out of alignment, then we would start thinking about maybe this is time for an ashless oil soluble cleaner. And this ashless oil soluble cleaner has the benefit of using that in the system for a month in advance prior to the outage, and then draining and then refilling with no need for a follow-up displacement flush. And then the most aggressive would be if your system is what we would call severe, and having severe varnish indicators, which means multiple indicators, which means you're having operational issues, and also you've got some oil analysis that is in a caution or an alert condition, and that would drive you to be in the more severe and more aggressive oil soluble cleaner. And all the above are best done with the use of a well-qualified flush company to support in these efforts. So once you've worked through that and decided the path you're going to need to take, now you've got to select what makes sense for you and your timing and your goals, and that's in essence is picking that path. And so then I'd offer in brief summary is it really comes down to kind of a 3-step process. Gather your basic information, leverage what we've put together as our triage chart, and then select the specific direction that is going to support your needs, and then implement. So that's my presentation, and I'm stand ready for any questions.
Hello. Does anybody have any questions for James? We can just wait a second to see if we get any. What are some frequently asked questions that you get when you discuss this?
Well, it always comes down, like in the displacement flush, what oil should be used as a displacement flush oil is because that oil is sacrificed. And so the primary response is the oil quality that you're going to be using on your fill. But sometimes you get challenged for economic reasons that they'd rather use a less expensive oil for that displacement flush. And there are times when that does make sense. And then oftentimes we'll offer, if we go to an unadditized base oil, will suffice in that manner.
Someone said, "Are you look?" I don't know if you're looking at the chat. Someone said this earlier.
Yeah, I see that.
Okay. So that was just saying, look forward to your presentation. We do have a question. How do you know when you need to do a displacement flush when switching brands compatibility tests?
Yeah, that's right. So and that's what really stems that part of it. There's ASTM 7155 that is a compatibility test regime, and that is your confirmation, and that's why you would want to do that displacement flush, because you'd be concerned about things like demulsibility foam, actually antioxidant interaction, also rust implications. So there are a lot of good reasons why you'd want to do that 7155 testing to confirm compatibility.
Are there any more questions anyone ask? Sometimes it takes a second.
I'll throw out one thing if another question doesn't come in. One of the concerns we've had with sometimes you get to a point where you're using a very aggressive cleaner, and the very aggressive cleaners are very good at cleaning systems. But the negative is that they can impact the following charge of oil. So it's critical to do that displacement flush to get that aggressive cleaner out. So it's very good at cleaning, but you've got to get it out of there, and you got to get it out of there below 0.1%. And so that's a significant displacement flush to accomplish that.
Our next question is, if there is a compatibility issue, what symptom typically is impacted?
Right. And so we would, demulsibility foam and oxidation stability are the three things that we would be of most concerned. And sometimes you can see an impact on rust.
What oil property?
With those, I mean, demulsibility is the ability to separate water. So that would be one of the key characteristics. But our experience with the less aggressive oil soluble cleaner is there is no impact on those key properties, including things like gear load protection. So that's some of the beauty of the chemistries available today in the less aggressive cleaners. It is that it does not impact, and then you don't have to go through that secondary displacement flush.
The ultracentrifuge testing, can you elaborate on this?
Yeah, so what they do is they take a sample of your oil and they spin it at 17,500 RPM in a test tube for a half hour. And then they drain that test tube out and they look for deposits. So we look at MPC as having a place to tell us about precursors for varnish formation, but the ultracentrifuge actually confirms that, yeah, we have deposits in this oil. So that's why we like to use them together. I just offer too, on that ultracentrifuge, our technicians or lab technicians then scale that on from 1 to 8, 8 being the worst, 1 being the best, and anywhere in between. And so we caution when we get to a 4. And that's when we're looking at that turbine oil triage. That's one of the key characteristics. We start looking at all those data points, the MPC, the FTIR, and we have specific cutoff levels for each one of them, and that helps dictate your best path forward.
We have, at what point would you use the oil soluble cleaner specific MPC UC results?
We would use those as you're going into that outage, and you're maybe a couple months in advance of a turnaround, and you're starting to plan for what do we need to do to. Oftentimes these turnarounds can be like in 8-year intervals, and so when a customer is coming down for his outage, they're planning long term, and they're looking at all the different things that might go wrong in the next 8 years when they don't have an opportunity to do anything to fix that oil or fix the equipment. And so that's when you would start in advance of that doing that testing. And like all oil analysis, it's best when you're done in a trend over time. So it's kind of a last ditch effort to get some testing done as the months approach. It's really beneficial if you've got years of data to help build a story.
Are there any more questions? Once the MPC UC has identified an issue and flushing has been carried out, is filtration, offline filtration then recommended?
Well, so your OEM is going to have a recommendation for oil cleanliness. And the generic oil cleanliness is an 18, 16, 13. So you would confirm what kind of oil cleanliness you have and then decide if you needed to improve upon that. And many times the full flow filters are suitable. Sometimes you do look for the advantages of a side stream filter, resin technology or high depth media are good candidates to help on the varnish side of things. But we look at if you have a good flush system, use a high quality oil. Mostly the system filters on the turbine itself are going to be able to get the job done, but you've got to confirm that through oil analysis.
If there aren't any more questions, what are some follow-up statements, if you have any, that you'd like to make?
Well, and again, it comes down to picking that quality oil that you can have confidence is going to go the duration that you're looking for. And so we talked yesterday about oils of yesteryear maybe only making 20,000 hours before having operational related issues. And now we've got oils out in the market that are over 80,000 hours and can go longer. So the technology has improved a lot, and then also these helpers have improved, like the ability to change your oil without aggressive practices. I think is a real key advancement, and the ability to change that oil without a flush is also a significant improvement, especially for a customer on a limited time schedule and a limited budget. And also when you look at like the sustainability side of things, flushing in itself is wasteful because you're going to take 2/3 of that oil flush and dispose of it. So here is an opportunity to minimize and save 2/3 of a system volume by using a technology and a practice that does not result in wasting of that flush oil. So I think that's a key element as people look forward to what their next step is when overhaul and outages are coming up.
So we have, does the oil need to be replaced once the soluble cleaner is added to it?
So there's different types of oil soluble cleaners, and we for years, 20 plus years, worked with a more aggressive oil soluble cleaner that does an excellent job cleaning, and that does need to be replaced because even 0.1% of the residual of that oil soluble cleaner is enough to impact long-term performance of the following oil. Now there are new technologies that we're working with that do not need to be replaced. And basically, if you drain down at, let's say, less than 2% residual, and you've got manual cleaning in tanks and that type of thing, you're not in a position where you're going to have to do that displacement flush and drain that oil out.
What is the main criteria for selecting a turbine oil for gas turbines?
I would say it's experience. And I think Greg had a presentation yesterday that looked at benchmarking. And when you look at a OEM's criteria to be qualified, it's got like 10, 15 different tests that really are good for telling you, yes, that's a turbine oil, but not very good for giving you a potential life expectancy of a turbine oil. So it really comes down to proof of performance. And that's where when you've got proof of performance that an oil is lasting 85,000 hours in an application that it used to last only 20,000 hours, those are significant things. So it's really hard to tie it to an ASTM test to identify one performance property of versus another. One thing that we rely on in ExxonMobil is our rig testing. We have these rigs where we accelerate the oxidation of an oil in a actual rig, and we look for things like valve stick, we look for deposits, and then we rate the system, and then we can compare that versus other oils in the market and our own oils, and then use that as our screening tool to improve the properties of the oil by formulation tweaks.
Any more questions? Got a thank you and a great job. All right, so there are no more questions. Would you like to make one more final statement?
Yeah, thank you. I appreciate the opportunity to talk to this group. And again, we wanted to put ourselves in a position of an operator that is looking at an upcoming outage, and because they're faced with a lot of different decisions, and we see the turbine oil as being a key element, the lifeblood of that turbine. And going in, they should know the best path forward. And there's a lot of different choices to make there, so it can get very confusing. It's not one size fits all because each plant, maybe the plant's going to be shut down in 3 years and they don't need that level, or maybe they need to run for 8 years with full reliability. So you've got to take all those things into consideration and their equipment they're running, and then make the best decision. So I appreciate the opportunity to talk about that. And that triage chart is something that we have available, and we would dig down a lot deeper and a lot more thorough sitting down with a customer.
So if anyone wants to connect, you can go to his page and connect with him, and you guys can chat and answer more questions if you are free to do that. Okay, thank you. Have a good rest of your day.
All right, thank you.
Bye.
All right.